So if it comes to the hydrogen, we are having 3 isotopes. So each isotope who is increasing, number of protons is always constant. Only who is increasing, guys? Number of neutrons alone is neutron. So this protium is called as light hydrogen, or else this is the basic hydrogen which we used to see in our surroundings also. So this is only called as heavy hydrogen. What we used to call? Heavy hydrogen, basically, which is present in between the star, interstellar stars, and as well as sun, and everywhere this heavy hydrogen is present. Okay, but on our Earth atmosphere, only light hydrogen is present. And if you calculate the average atomic mass of hydrogen, what is this? Average atomic mass of hydrogen, which is used to come equal with the abundance percentage, which will come around 0.10 U. So we can rounding up to what? 1 U. So that is why atomic mass of hydrogen, we can take how much, guys? Hydrogen atomic mass is equals to 1 U. Understand? So if we'll find average atomic mass, it is coming 1.01 something U. So that is why we will consider as a 1 U. That is it okay? Yes, Monish? Devasini, that is how to understand it. So now if you notice it very carefully, so now still so many not there. So this is what we used to call as average atomic mass. So we can say hydrogen if we'll take. So we have three kinds of isotopes for hydrogen. So now in exam, they will ask you to draw the structures also. So the first one is called as what? First isotope, what we used to call? We used to call as protium. Understanding? So that is only we used to call as ordinary hydrogen, or we can say simple hydrogen. Understand? And the second one is called as deuterium. It is called as heavy hydrogen, and tritium is called as very heavy hydrogen. So everybody draw the structures. Isotopes of hydrogen, down you have to draw the structures. In exam also if they'll ask, you have to explain with the diagram, so that everybody will give the good marks to you. Okay, so that is what. Do it fast. Aswita not joined, and one more fellow not joined. Who is that? I don't know. Tamil Selvan. Okay, write it fast. So this is what we used to call as isotopes of hydrogens. So draw the structures, everybody. So now, same way, if we take isotopes of carbon, draw, you all of you draw. So down only I will say. So if we take isotopes of carbon, so carbon is having 3 isotopes. What is atomic number, Ra? Atomic number of carbon, how much, guys? 666. So number of protons, mass number varies from 12, 13, and 14. So what is the most standard form of carbon? Carbon 12.
Carbon 12.
12 is the most standard form. So these are called as isotopes of oxygen. If they will, carbon. If they will ask you isotopes of oxygen, then oxygen also having 3 isotopes you can write. So oxygen also 888. What is atomic number? Oxygen 888. It is varies from 16, 17, 18. 16, 17, and 18. So what is the most abundant form? Most abundant form is 16. So that is why we will take that. Next, if we take isotopes of neon. So neon is a what? Noble gas. Yes or no, Sai? Neon is a noble gas. Yes, guys? So but still it is having isotope. Ne, Ne. It is also 3 isotopes. So we will take neon atomic number. How much, guys? So neon atomic number is 10. Yes, 10. But number of neutrons varies from 20 to 22. So 20, 21, 22. So these are the different isotopes which you people need to study. So make it everybody. So this is isotopes of carbon. So these are the elements is enough for you. So your textbook only they have given hydrogen and as well as chlorine. But you are studying little bit even more. So you people can make this all. So carbon, but in exam they'll ask you draw the isotopes of hydrogen. Definitely either chlorine or else carbon, hydrogen, madam will ask. So be very careful and do that. So ordinary hydrogen we used to call it as protium. Atomic mass is 1 U. You have to draw like this. So they will ask you the question: which hydrogen does not have any neutrons? Which hydrogen it is? Which hydrogen does not have any neutrons? Which hydrogen does not have any neutron? Protium. And which is the yes, protium, which is having very simple heavy hydrogen, tritium, and very light hydrogen is protium. That is what you have to remember it. So now if you take, sir, you may be right. Till here you finish it, everybody. Any doubt anybody you can ask me? So carbon isotopes, oxygen isotopes, and as well as neon isotopes also you can write it. So this is what the other examples of isotopes. Is it okay, everybody? Sakti, Sai, Shruti? That is what you have to remember it. So now we will continue from here. So now here you might be get by this time in your mind, maybe having a doubt. So as we know, for example, take, let me consider. Now you can see, for example, let me start with two persons. Let me take Monish and as well as Maitreyan. Now if you take, both are called as humans. Yes or no, guys? Both are called as humans, and there appears what? Appears to be what? Both are physical state, both are appears to be in a solid state. Yes or no? Physically there appears same, and the chemical reaction also you can take. So he also will eat food and he also will eat food. He also will do the chemical reaction in same way like respiration. He also will do the food releasing energy by the respiration. Now, if it comes to the isotopes, is it they're having same chemical properties, or is it they're having same physical properties? That is what the most important thing. So if we'll take here, let us come to the first chemical properties. If we'll take all the isotopes, maybe their mass number is different. Do you understand what I'm saying? Their mass number is different, but they will follow a similar chemical properties. Do you understand what I'm saying, guys? Because in chemical reactions, who is involving, Ra? Who is involving in any chemical reactions? Any chemical reactions, who is involving?
Electrons, sir.
Electrons are involving. Electrons are involving. So, use of number of neutrons. So, mass number or isotopes does not going to affect any chemical reactivity. So, all the isotopes is having same chemical properties. That is what I can prove. Is it yes or no, guys? Because the chemical reaction will followed by what? A chemical reaction will followed by electronic configuration. Yes or no? Please respond. So electrons will decide what kind of chemical reaction will take place, either donating or receiving or accepting, sharing. So it will be depend upon the electronic configuration. Yes or no, Jayavashini? So that is why chemical reactions of every isotope is same. They have identical chemical properties. That is what you have to remember. So right, all the isotopes of an element have identical chemical properties. All the isotopes of an element have identical chemical properties. Because why? Chemical properties. Because why, guys? Because mass number does not affect the chemical reaction. Only who will affect the chemical reaction? Aswita? Only electronic configuration, means the number of electrons arranged in a valency cell will decide either it is more reactive or less reactive, or donating or sharing. Yes or no, guys? Alana, everybody? That is what you have to remember. So that is what, please write it. The identical chemical properties of all the isotopes of an element, the identical chemical properties of all the isotopes of an element on the basis of whom, guys? Shakti, on the basis of their electronic configuration, on the basis of their electronic configuration, on the basis of their electronic configuration. Is it okay, Aswita?
Sir, the
identical chemical properties of all the isotopes on the basis of their electronic configuration, example. So let us take example, guys. Everybody take example of chlorine again. So chlorine example, tell me everybody, two examples are there. What is the first isotope? Cl 1735. Cl 1737. So now
37.
Write the number of valence electrons. Now, number of cells, how many? K, L, M. Here also how many? K, L, M. So now if you notice it, 2, 8, 7. Here also how many? 2, 8, 7. Because
2, 8, 7.
electrons is a money. Number of electrons 17. Number of electrons is 17. So if you notice it, here also it will receive 1 electron. Here also it will receive 1 electron. So this valence is also how much? Chlorine -1. This valence is also what? Chlorine -1. Yes or no, guys? Please respond. Everybody. So valence,
Yes,
even though mass number is differs, valence is same or not? Devarshini, Laksha. So that is why we can say, because electronic configuration is same and the number of cells, if size is increasing, number of cells is increasing, guys. Number of cells is constant, yes or no? So number of cells also constant. So the number of electrons also constant. So that they're having same identical chemical properties. Will you accept it, Maitreyan, Sai, everybody? So that is what you want to say. So might be having different atomic mass or mass number, but they are having same number of electrons and electronic configuration. So that the chemical properties are what? Chemical properties are identical. Is it okay, guys? Everybody? Yes or no? That is. So now, next one, second one, physical properties. Let us come to the physical properties. Now, is it physical properties are same or not? We have to study. So, physical properties are not same. They are slightly varies between the isotopes. That is what we will study now. So, please all of you keep right. The physical properties of an isotopes, the physical properties of an isotopes of an element are not same. Are not same. Why, guys? Somebody is heavy. Why? Because of somebody is heavy, somebody is lighter. So that the physical appearance is same, guys. Tell me, please. Suppose, for example, if we'll take me and Mukesh Karthik is little bit looks like he's having little bit chubby carrot, but I am very thin. Like that, you can see, is it the physical appearance? Because maybe his mass is more, my mass is less. I may be like very long, he may be little short. Like that, the physical properties of an element depends on mass of the atoms. It is depends on whom, physical properties. Physical properties depend on whom? Mass. But chemical properties depends on whom? Chemical properties depends on whom? Chemical properties depends on electronic configuration. Whom it depends on? Depends on electronic configuration. Chemical properties are identical, but the physical properties are depends on atomic mass, or we can say mass number. So that if atomic mass is varies slightly, so that physical properties also varies or not? Please respond. So since atomic mass A is varies between isotopes, so that what is happening? So physical properties also varies slightly. Is it okay, everybody? Yes, please respond. Sai, that is. So what is the statement you written till where? Elmokil, can you say? Till where you written?
Physical property of isotopes are not.
Yes.
Properties of an isotopes are not same.
Yes. The physical properties of isotopes of an element are not same, or you can write different. Are not same because the physical properties depends on whom, Sakti, Sai? Physical properties depends on mass of the atom. 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 Do you understand, everybody? Please respond. Shruti, Laksha, Mass of the atom. Since the masses of the isotopes of an element, since the masses of the isotopes of an element are slightly different, since the masses, not mass brothers, masses, because different masses, correct? Since the masses of the isotopes of an element are slightly different, or varies, so the physical properties also, so the physical properties of the isotopes, slightly different. So what do you mean by physical properties? Maitreyan will give example. Maitreyan, any physical property? Jayavarsini, what do you mean by physical properties? Any example of physical properties? Please. Examples. Density, melting point, understanding, MP, you may be studied, yes or no? Melting point, understand Ra? Next one.
Yes, sir.
Yes, sir.
Means what? Boiling point. Understanding, boiling point, like these things will vary. These are only called as physical properties. Understand everybody? So mass is increases, density increases or not, because we know that the density is equals to what is the formula? Density is equals to mass by volume. So density is so mass is increases, density increases. So that is what. So if mass is more, even melting point and boiling point also may increases or decreases. That is what it is. Understand, Mukesh, Karthik, Shruti? So chemical properties of isotopes are same because of same electronic configuration. See, this much in detail nobody used to discuss also, because if you'll see in our book also, chemical properties and physical properties, there may be single line they'll say. So chemical properties of isotopes is same, physical properties not same. That's all. They won't say anything. Why it is not same? Chemical properties, why it is same? Because even though they are having different atomic mass, but who is constant? Electronic configuration is same. So the number of valency cells are same. So the number of donating electrons or receiving electrons or sharing electrons are same. So that chemical properties depends on only electronic configuration. But if it comes to the physical properties means what? It is depends on atomic mass. So since the isotopes are having different atomic mass, so their physical properties also slightly varies. So examples what are? Like densities, melting points and boiling points, etc. So this all the physical properties depends on whom, guys? Masses of the isotopes. Masses of the isotopes. Understand everyone? Yes. That is what you have to remember. So example also you can write same thing again. What is the example? You can say physical properties of chlorine 1735 is little slightly different. Understanding? Little different between what? Chlorine 1737. Understand? In which one it is differs? Different from in physical properties like density, melting point and boiling point, etc. So this is what we used to call as isotopes. Understand everybody? Please respond. Yes or no? Yes. So that is what you need to do it. So like this only, everybody need to find what is the average atomic mass of any kind of elements. Now, I will give you one question. So everybody try to solve that one. So find the atomic mass of that. It is actually from your book only. As I said, bromine. Bromine is occurs, understanding, mainly in two isotopes. The two isotopes I will give you. Now everybody find what is the average atomic mass of bromine. Shall we do it or not, everyone? Yes? So this is what the bromine. Everybody start doing it now. So this is, it should go up 1 minute. So what is the bromine atomic mass? Atomic number 35. Okay, guys. So bromine atomic number is what? 35. Atomic mass is varies. So abundance also I given. So this is 35, 79 present 49.7%, and this is present 50.3. So find the average atomic mass of this one. Everybody must solve it. Slowly, neatly solve it. Make it fast. Slowly solve it.